In this video, we are going to explain another property for Fourier transform, which is time reversal. We know that if we have a continuous time signal x of t, it will be x of omega. So what happens if we have time reversal here? If we add negative sign to the t, you will add negative sign to the omega. Or in other words, if it's a complex, you will have the conjugate of the Fourier transform of x itself. It means only you change the imaginary part. Well, just let's have a simple example here. In this example, we have this function, all right? You can write it in two separate statements. x1 of t, the one on the right-hand side, it's exponential 1, which is equal to e. And let's say it's equal to e minus 2t ut. If just we ignore this part. So that's the function that we have, the x1 of t. Let's get back the other function, x of t. x2 of t, it's the same, but like inverted. So every t will replace by negative t. So it will be equal to, just let's write in half space here, x2 of t will be equal to e 2t u of minus t, because it's defined to the left. And y of negative t, it means from negative infinity to 0. All right, I want you to understand what does mean u of t. It means it's equal 1 when t greater than 0 and less than infinity. When you make u negative t, it means from negative infinity up to 0. All right, so that's right. The signal only left. So we have formula for this one, but we don't have for this one. Well, let me refresh your memory. If you go for the table, you'll find this formula for the exponential function, e minus bt ut will have a Fourier transform equal to 1 over j omega plus b, and the condition in this one, b should be a positive number in this formula. Okay. If you apply this to x1 of t, you will have, if you compare both expression, you will find that b is equal to. So I'm going to say now x1 of omega will be equal to 1 over j omega plus 2. That's x1 of omega. And if you go for x of 2t, you can use now the time reverse property. You are going to get the conjugate of this expression, because x2 of t, it's equal to what? Let me write the expression for x of t again. x2 of t, it's equal to e 2t u negative t, which exactly equal to x1 when you replace every t by minus t. If you replace t by minus t, you get x to t. If you replace t by, that's right. So I will just go ahead and apply the time reversal property by taking the conjugate of this one. It means only I flip the sign of the imaginary part, would be minus j omega plus 2. So that would be x2 omega. Well, if you want to find Fourier transform for the whole thing, and actually this one can be written in compact form, you can write it like that. Y of, I'm sorry, it should be of t, it should be lowercase y of t. If you write like e to the minus 2 absolute value of t, that will give you the same thing. If t is positive, will be e negative t. If t is negative, will be e to t. That's right. So actually, we are going to find Fourier transform of the whole thing. It's equal to the summation of both. So y of omega will be equal x1 of omega plus x2 of omega, which equal to 1 over j omega plus 2 plus 1 over minus j omega plus 2. And you can simplify it. by having a common denominator, and just I'll write it like 2 plus j omega times 2 minus j omega. When you do that, so you multiply this top and bottom by 2 minus j omega, and you multiply in the top and the bottom by 2 plus j omega. So you'll have in the top 2 minus j omega plus 2 plus j omega, and now we have common denominator. So 2 and 2 is equal 4 in the top, minus j omega and plus j omega will cancel each other. What about the one on the bottom there? Well, you multiply 2 by 2 is equal 4, and 2 times minus j omega will be minus 2 j omega. Then we start multiplying j omega by 2 plus 2 j omega, and then you have j and minus j square omega square, and we know j square is equal to -1. So you can write 4 over, and you got something here. It's going to be easy. This part will cancel this part, they are equal. So you have in the bottom there 4, and there's negative, j square -1 times negative will be positive omega square. So in this case, Fourier transform for the function that we have here is equal 4 over 4 plus omega square.